even though the term momentum is an outdated term when compared to energy. And of course, the law of conservation of energy can be applied to any of these situations in which we will be applying the law of conservation of momentum. The law of conservation of momentum is still valid, and it still works. And using it in many of these situations is more simple, and it leads to faster solutions than applying the law of conservation of energy. So it's still a good tool to use in many situations. What does the law of conservation of momentum say? Here we have a system, in this case a box, and the net force acting on the system is equal to 0 newtons. Now if you remember, the impulse and momentum theorem says that impulse changes the momentum of a system. There's the equation for the impulse momentum theorem. So if the net force, if this value right here, the net force applied to a system is 0, if the left side of the equation is 0, then of course the right side of the equation also has to be 0. So if no impulse is applied to a system, then that implies that the system goes through no change in momentum. And to say that there's no change in momentum is the same thing as to say momentum of the system is constant, not changing. And that's what the law of conservation of momentum says. We could write it as that the law of conservation of momentum says that the total momentum of a closed system is remaining constant if no net force is acting on the system, of course. So in the absence of net force acting from the outside, the momentum of the system is remaining constant no matter what is going on inside of the system. So inside of this box there could be things colliding and hitting the walls and doing whatever. If there's no outside force acting on the box, on the system, what's happening inside does not change the total amount of momentum that the system has.